Hi guys, nice to see you back. Today we go one step further. Remember last time we've made a little number 347 with 0.56 inches size digits. Today we go for 0.8 inches. It doesn't look like being a big difference, but take a look when you energize it, how big the number is. This one from the last time, and if I connect the second one, you're going to see the difference. Okay, so 0.56 inches versus 0.8 inches, but surely it won't be just that difference today in between the two projects. Is gonna be a bit more. So the one we've made last time, it could only be changed if you were rewiring the whole circuit. It's no big deal finally, because it's cheap and you can do this when you move from time to time. But today, not only we add bigger digits, but we insert some other parts to be able to actually change the number anytime we want. Like here, if I want to simply reset my number, I can simply put everything off, you see here. And if I want, I can pick up other number. Let's say I make it 1 on here. I make this one, let's say 7. And I can make this one 1 again, 171. I'm not happy with this, no big deal. I can make changes, so I can make it 173. I'm not happy with this, it's no big deal. I can change it like, I don't know, we make it let's say this one, that one, we need E and we need D. So to 13. So I can change any number I want this time. Now remember our old discussion about the digits. We need to follow some steps. The steps are: identify the commons, because there are two sides of the package. Last time, the terminals were arranged top and bottom. This time they are arranged left to right with respect of the digit itself. So it's going to be a bit different. So again, first step, identify the commons. Second step, identify what kind of digit you have. Is this a common anode type or a common cathode? And the third step, identify what segment goes on what terminal. And after you did this, you make your chart, then you can do the wiring. We go back to this. What do you need for the project? You need a prototyping board. This one is easier for people more comfortable in the metric system, because it's 6 centimeter by 8. In inches is a bit weirder. It's something like 2 inches and 3/8, 2 inches and 3/8 over 3 inches and 1/8. Okay, so this is why it's a bit easier in centimeter, because in centimeters is 6 by 8. This is the board we need, and even so is a bit on the edge, at the limit, but I managed to mount everything on it. The parts. You need the network resistors. Remember, I don't know how to put it here to show this to you again. There is a dot, a gray dot on the package, and I'm sorry, I only found the black packages, I didn't find the light brown ones. So there is a dot, which is the common. This package has 8 terminals, because one is the common and the 7 remaining are for the 7 resistors. We have 7 segments, we need 7 limiting resistors, and all of them are here inside. So you need a network resistor. Remember, you're going to find it very easily on abra.com, abraelectronics.com. Then you need the 7 miniature switches. They are packed exactly like an integrated circuit with the same footprint. 14 terminals, 2 terminals per switch. They are just sliding switches, very easy to use. And this is how we're going to be able to change our number anytime we want. And of course, we're going to need the 7 segment displays, 0.8 inches size. And if you know what to look for, you just have to look for the number 3401. 3401. The letter R at the end, it just says is a red one. So you may have it G from green, you may have it Y from yellow, and so on. But I'm using the red one, is the most common and the cheapest one. The series of the packages is 3401, okay? But then you're going to also notice that this package has some missing terminals. Here on this side is one missing, and on the other side, there is also there are 2 missing terminals. And when you take a look from the top, this is what I drew here in the red frame. I'm gonna take this one aside to be better seen. Here in the red frame in the top, I put the pin numbers 1, 2, 3, 4, 5, 6, 7 and 8 are missing. That's what you see here. Then on the other side, 9, 10, 11, 12, 13, 14, 15 is missing, and 16. Be careful, because this is a kind of in-house numbering system. The system you're going to find from the manufacturer is going to contain 18 terminals instead of 16. They have one here more in the top on each side, which are not existing, they are missing. So I just eliminated them and numbering the terminals 1 to 3 to 8, 9 to 16, okay? I have to tell you in advance here, because it's going to be a bit more difficult for beginners. Instead of having one common on each side, remember the 0.56 inches we did last time, and it was having the pin 3 and the pin 8 in the top, pin 8 in the bottom, pin 3 related together, and both of them were the common. This one has more than 2 terminals related together inside the package. Is this one here? I numbered the pin number 3. Is this one here? Is numbered 5. Is this one here? 11. And this one here, 16. Inside the package, all of them are related together by wiring, like this. So there is wiring going to these terminals. So you only need to use one of them, you don't need to use all the 4 of them. But it's like that because the manufacturer wanted to give more flexibility to the designer of these printed boards where the packages are used. So as you can see, I'm only using one of them. And I'm telling you, I discovered already that this kind of package 3401 is a common anode package. Common anode. This is why I took a wire from here and it's gonna go to plus 5 volts. Let's check it out. We have our meter, and we're gonna put it on diodes, okay? And then we pick up wires, and I placed my wire here in the top on the pin 16, and then I'm moving the other wire around. Hear the sound? So here is the pin number 3, which is the wire related together to this. I'm jumping from here 1, 2 pins, 1, 2 pins, and I find another one, which is also related to this one. And if I go on the other side, and I go from here 1, 2, 3, I go here 1, 2, 3, I'm gonna find the 4th one, which is common, okay? Now, I wanted to know, what kind of common is this? is this a common anode or a common cathode? So, because the meter is going to inject just a bit of amperage inside, I'm going to put the light off because I want you to see what happens. Take a look. I can see the light on one segment. This is the segment F, okay? If I see the light on this one, I have to consider what is here. Is the black of the meter. The black is like going to the cathode, and the red is to the anode. So, the terminal related to the red should be an anode, and the one related to the black should be the cathode. But the red is related to the pin 16 on the top right. So, is a common anode. And this why, if I move, here is the pin 4 on this side, the pin 3 on this side. I have to move one pin further. This is E. That's exactly what I put here, E. Then is 5, because it's another common. Then, if I move it here, is the left decimal point. I don't use it right now, but it's existing, and that's how you identify the position of it, okay? So then I'm moving on the other side. So if I move on the other side, I'm going to find out the right decimal point of the pin 9, okay? I move it one pin higher. I'm going to find D. So D. If I move it one pin higher, it's going to be a common. This is D. That's the common. I move one pin further. I'm going to find the C. I'm going to find the C. Then I should find on the next one G. Is right here in the middle. And finally, I'm going to find the B. I'm going to find the B. The next pin is missing. And then we have the common. So don't worry about this, because you are going to find the arrangement of the terminals, exactly that page, the component side. You find it in your folder on the Google Drive, okay? Now I have to tell you, how do we arrange the components? The components can be arranged in 3 distinctive ways. This is the simplest possible way. You pick up the 3 digits, you place them exactly like here, and then you pick up the three groups of switches, the dual inline packages, and you put them exactly like this, okay? So you leave something like 1, 2, 3 free holes before you insert it. Right below, let me just take a pair of tweezers. Right below, on the next row, you insert the network resistors, but be careful, because the common has to be out of the group of switches on the next row. So the 7 pins are exactly going 1 per switch, and the common is out of the switches. So you put them 1 here, 1 here, 1 here. And finally, this time, because the board has the holes a bit larger, you are going to insert your little 2-pin terminal block, and here you are. That's the first arrangement, okay? Here is actually the position of the 7 switches, and here in the bottom, the position of the network resistor, okay? The one I'm using, let me put the power off for a second. The one I'm using is a bit different, because the group of switches is arranged, the package, exactly like an integrated circuit, exactly like a 14-pin integrated circuit. It can be placed on a socket. So, instead of placing it directly on the board and soldering it, what did I do? I placed a socket here first. And if you take a closer look on the socket, you're gonna find here, like for any integrated circuit, the notch on the left side. So I lined the notch with the printing on the switches. So my switches go from left to right, 1, 2, 3, 4, 5, 6, 7. And also you can notice then that when the switch is down, is off, and when the switch is up, it goes on. It's written on the package, okay? So that's how you know which is which. So the second arrangement again, instead of having all components straightforward planted on the board, I put the switches on sockets. For me, is an easier move because this way I can check a switch if I have doubts about it. Okay, I can check it. I pick up the package, I remove it from my board, I insert the one I have doubts about, and I can check it right away. And the third arrangement you can do is more complicated. Not only you can put the switches on sockets, which you know, but you can also put the digits on sockets. What kind of sockets you need for that? Take a look. This is a 24-pin socket for integrated circuits, for larger integrated circuits. For this distance between the two rows, which is 0.6 inches precisely, okay, you won't find such a socket for 16 or 18 pins for this digit. The smallest one they make, this large, is 24. So we're gonna pick up 24, exactly like this. So then, as you can see, it's fitting precisely inside. It's not a problem, okay? And then you just plant it right here on the printed board. So then you can do the soldering. Now, what about the soldering? Let me remove this one. We don't need it anymore. Okay. We can put this one aside to make more room. Okay. For the soldering, you're going to need the second page, which is this one here. So this is exactly the previous page in a mirror, okay? Exactly the same picture, flipped 180 degrees like in a mirror. It's because this is the component side, but when you have to solder, you have to flip it this way. So when you flip it this way, what's interesting is even if the circuit looks more complicated because you have to insert your switches on the way, something the older circuit didn't have, okay? But all the three digits have to be wired identical way. So you don't have to wire for every number a different wiring. All the three digits, or it doesn't matter how many you need, because for some of you only need 2 digits if your apartment number only has 2, or you may need 3, like this example I've made here, or you can use a larger board and you can make it 4 or 5 or whatever is the number you need, okay? I hope you won't have the number 5 for your apartment, but I'm just saying, if you want to use it for any other purpose, you can extend this any long you want, and all the digits are gonna be wired identical way. What's gonna be common for all? The wire in the bottom, which is the ground, and the one in the top here, which is going to be the positive. As you can see, the wire in the top, give me just a second. Okay, so the wire in the top, this one, comes right here, and here, as you can see, is a red wire representing the positive, and the one in the bottom right here, is the ground, and I use for that a blue wire. So far so good? Excellent. So then, if this one is done, then we can energize it and finding out how can you change the numbers. It's very easy. Because this time we can pick up any numbers we want and we don't need to rewire anything. We only do the wiring one time and that's it, okay? So let's take a look right here. We're going to pick up random numbers just to display, okay? Let's say for the one on the left, I pick the 3. It's no big deal. If I start from scratch, Remember, tree has 5 segments: A, B, C, D, and G. Take a look. We take them in order. A, B, C, D, and G is the middle one. That's 3. Let's pick up the second one. Let's say it's 9. As you can see, 9 is all the segments on, excepting for E. So we have A, B, and C are already on, D, F, and G. This is 9. Let's pick up another one for the next 4. Okay? 4 only has 4 segments on, B, C, F, and G. Take a look. B is the second one, B, C, F, and G. And you have 394. Now let's suppose you are not on the 3rd floor, you are on the 2nd floor. No big deal. You're going to need to do some changes. First thing going off is going to be the C, this one, and instead you are going to need the E. So the floor number 2. And let's suppose you have 17. 1 here and 7 here. 1 is B and C. All the others are off. Take a look. And 17 is A, B, and C. And all the others, they go off. 217. Oh, you move to another floor and you move to the last one, let's say the floor number 8. And then you move on the, I don't know, 26. You make 26. It's very easy. Okay? So you don't need the C, but you need the G, you need the D, and you need the E. Okay? So you need A, B, D, E, and G. And then I said floor number 8, 26, 26. Sorry, it wasn't this one. Okay, here 26. In order to make the 6, you already have the A. All segments are going to be on excepting for B. So you put all of them on and you get your 6. A26. And this is how you can change to any number you want. Okay, this one versus the older one. Okay, now one other thing, maybe the last one you may be interested about, is what is the consumption is this? What can you use as a power supply? Let's first put everything to 0, to off actually. Okay, I go all of them off. And by maintaining the power supply on, I'm going to connect the ammeter, which is right here, and we're going to monitor our consumption. So let's put our meter on 400 milliamps, like this. We pick up the amperage on DC, and then we're going to connect the wire right here. Okay, so this one is gonna go here, and this is gonna go right here. Good. And then we only put one segment on, any segment you want. Let's say I'm gonna put the G right here in the middle. Okay. What is the consumption per segment? 9.7 milliamps. Let's roughly saying 10 milliamps. Okay. This is one way to do. You measure the consumption for one, okay? But you can also measure the consumption in the worst case scenario. What is the worst case scenario? When you have all the segments on. Because that's how you find out what kind of power supply you need. To see in the worst case scenario, what is the maximum consumption you can get, okay? In that situation, you take a look here, is approximately 170 milliamps, okay? Let's say roughly 180 if you want. I have here 1, 2, 3 digits. Each of them is wearing 7 segments. 7 times 3 is 21. So I'm picking up here 180 milliamps. I exaggerate because mine is not consuming that much. And dividing by 21, I'm gonna get a consumption approximately 9 milliamps, 8.5, almost as before, okay? If you want to make sure your consumption is covered well, then you can say 10 milliamps per segment times 21 segments in total, like here, the worst case scenario, is gonna make 210 milliamps, even if in reality is less, okay? Any phone charger, old one you have in your junk box or forgotten in a drawer, is going to do the job because the voltage is 5 volts and the consumption is usually not higher than 200 milliamps. Okay? So, what's the next step? Because this one you understand very well. You're gonna find the two pages on your Google Drive. Next is gonna be this one. This one is exactly the next one, which is 2.3 inches size, and this time it won't have 7 segments like the ones we used before, but it's going to have 16 segments. How do you manage this one? We're gonna see this next time. Thank you very much for watching, guys. Bye-bye.